Hi. I'm really happy to be here. Thank you for coming to the OpenNebula conference. I hope you're excited to be here as I am. So I work for Akamai. Akamai is a company that has a global network of servers distributed, all over the world in various data centers at different ISPs. Let's throw some numbers up here just to give you sort of an idea of the scale of sort of the server deployment that we have. 132,000 servers. They're all over the world, 2,200 locations, in all these different networks and all these different cities. And so you can see this is really distributed globally. And we're delivering, all this bandwidth, 10 plus terabits per second, sort of at our peak times a day. I think we just hit, I don't know, what was it, like 18 or something the other day. And so we're pushing all this data, I guess, because Akamai's our primary business is what's called a content delivery network. And so that means we're taking the data of our customers, like the web pages, the iTunes songs, the Facebook pictures, and we're sort of distributing these all over the world so that like our customers, end users, can get to these with lower latency and much quicker than they would be if they're being delivered from some centralized server. And you can see, like, it's an impressive number up there, 15 to 30% of web traffic. And obviously, this is probably very, certain times, I guess, maybe it hits 30% at some point. But we do hit, it's a significant amount of the web traffic at certain points in time, I guess. So Akamai is really, it's an impressive company. We've got an impressive set of servers out there. So I'm just trying to give you an idea of sort of the problems we're trying to deal with. So I'm a software engineer at Akamai. I'm working on the platform infrastructure team. And so my team sort of deals with the sort of layer of software that goes on every single server out there that provides sort of the infrastructure services, that like basically the other Akamai services that sit on top of this use. And so I joined Akamai a few years ago. I was working on the communications infrastructure team, and I was just on a sort of a relatively small corner of the world. This little piece of software that we use for doing messaging between all of our servers. This distributed messaging system that sort of underlies the service, the magic of Akamai that sort of maps the entire internet to sort of map the right user to the right server at the right time. And so I was working on the thing that allows this mapping system to do its communication. And I had some difficulty initially, trying to make changes to this particular piece of software because this thing was, deployed to all these servers, and it's not a super complex piece of software, I guess, but because it's so distributed globally, it was sort of difficult for me to know that, like, well, this bug fix that I'm making, is this really fixing this bug? Is it causing another bug? It's hard to tell because the behavior is so unpredictable in this world of like these servers that are distributed everywhere and like latencies, and especially from like a reliability perspective, this change that I'm making, is it sort of going to be continue the sort of dependability that we need in order for our system to work correctly. And so I feel like part of the problem that I was having is that sort of a lack of a realistic environment in which to test this piece of software. And it's like I was in the lab. We have some kind of ability to sort of get our stuff into a sort of a lab testing environment, but it wasn't realistic enough. And so I felt there was like sort of a real lacking for that. So a year or two later, I found myself in a slightly different role, a little more of a generalist kind of role, and I found myself in the position to sort of look at addressing some of these problems. So the problem I'm addressing right now is how to get our platform software, the software that underlies every single server at Akamai, how to get this out faster and with a smaller likelihood of disruption. Because we find that every single time we make a new software deployment of this platform software, there's some guy that sits on top of here that is is using this software in some unpredictable way, and we're finding that it causes some disruption. And we're using OpenNebula to do this. We found OpenNebula to be a great thing, and I'm going to tell you a little bit about how we're using it. Yeah, okay. So like I mentioned before, Akamai's globally distributed cloud of physical servers. Machines at Akamai are grouped into functional units called networks. We have edge networks, and so these provide sort of the services that we sell to customers eventually. And so we have CDN services. CDN stands for Content Delivery Network. We have object and file storage. We have analytics, and these are all sort of things that sit at the edge. We call them edge networks because they're at the edge of Akamai, the closest that we can get to the end user. And along with that, we have what we call infrastructure networks, and these sort of provide the services to these edge networks. And so we have various systems. We have distributed file transfer, we have messaging, we have monitoring, reporting, and so these allow us to do pretty cool things. Like we can take a file and basically distribute it out to all of the servers on the Akamai network within a couple of minutes in a very efficient way. And sort of similar thing with the messaging. And we also have this reporting system, this monitoring system that allows us to have each server out there is like exporting data, and it goes into these aggregators that live in one of these infrastructure networks and allows us to basically execute SQL queries that allow us to you look at the state of every single machine and continuously monitor the state of every machine just by running select star from machine details and like see the state of that machine. And the nice thing about it is that every single application can sort of export its own table, and so we can see all sorts of interesting data that way. But it's difficult, right? We have this software that's where the network specific software, which is I haven't really talked about that much, but we have this platform software that sits underneath, and the problem here is that the platform specific software is sort of on an independent release cycle than the network specific software. And we find ourselves as the people that develop this platform software in the position of trying to make the teams that sort of maintain these disparate networks that we're talking about, these edge networks. We find ourselves in the position of trying to convince these people that yes, the software we're developing and these changes that we're pushing out, yes, they're not going to break you, and yes, they're actually going to provide the feature that you want safely. And so that's the problem we're trying to deal with is to allow that to happen safely. And so we've been going through these measures to basically try to package this up and make it easier to consume for people, but we're still having problems with this. And so this is just to sort of give you an idea of sort of the organization of this stuff. We have an infrastructure network here, and this is there's one server on here. This is representative of one server, but there are multiple servers, obviously in each of these networks, and there are multiple of these edge networks. We generally have like this software here that sits on the infrastructure network, and then we have the network specific network that basically talks to the software in the edge network, and that communicates with each other, and we interact with in order to sort of interact with the service, we have to talk to the software on the infra network. But the software that sits out there on the edge network is generally where we see the problems, because we see the scale is much larger, because these edge networks are typically on the order of you saw before, tens of thousands of machines. And on the infrastructure networks, we might only be on the hundreds or thousands of machines. And on the edge networks are typically where we see the software really pushing the limits of the design, the operating system, and the hardware. So we're seeing problems with memory pressure, CPU starvation, and I/O starvation, and that's typically where our software starts to fall over. We're not handling sort of that error condition exactly right. And that it causes it to fail in a bad way, I guess. We're trying to avoid those sorts of problems. And we even find cases where the edge networks are using our platform software in maybe an unexpected or even unsupported way. But unfortunately, once something becomes used in a certain way, I guess it's difficult for it to become unsupported. Anyway, so we're trying to test our software in a realistic way. Okay. So let me sort of back out a little bit. We're trying. So what we want to do is to be able to realistically sort of represent the state of a network. We want to be able to sort of. We have this edge network here that we're trying to create sort of this realistic environment. But in order to do that, we sort of want to be able to represent the state of this thing somehow, because we want to be able to basically build one or create one. Unfortunately, while a lot of the state of a particular network is known and reproducible, like such as basically the software that's installed there and the configuration of it, and sort of a lot of times the dynamic configuration of this thing is known. When I say dynamic configuration, that's like configuration that can change outside of a given software release. But unfortunately, like the persistent state of a machine or a network can change, and like the database state or like stuff that's on the file system, and like there are often manual changes that occur for a given network at a given time, sort of to like something that might be required to deploy a given release of software, or to something might be required in sort of an extraordinary condition. And each network tends to have some kind of built-up state that's necessary for it to function properly, and this is never well documented or well defined, unfortunately. And so we find ourselves in this state where a given edge network is not something that we can just take and build. Each edge network sort of has an expert or a set of experts that know how to create these things, know how to build these things. But us, being in the platform team, don't have a way of sort of just taking this edge network and building it, and being able to sort of take this edge network and put it with our platform software and put it against our infrastructure network and do this in a realistic way, without having this expert on the edge network to tell us about how to configure this thing. Let's see. Okay, so let's zoom out a little bit and think about think about a set of Akamai networks, right? So we're talking about a particular network is difficult to reproduce. Sort of zoom out on that problem and say, well, we want to be able to take all of the networks that sort of exist in sort of the Akamai ecosystem and try to represent those. So I talk about the notion of an Akamai instance. When I say an instance, I'm talking about the idea that Akamai, a particular the deployed network of Akamai is an example of an Akamai instance. It's you take all these networks together, and each has their their component machines, and you put all these together, and you have something that provides these Akamai services that we can sell and make dollars and cents from. And so we have one of these, and each one of these Akamai instances is self-contained. It's got limited external dependencies, and so that sort of gives us some freedom. And so obviously we have multiple of these instances. We have the production instance, which is sort of on the order of 10 to the 5th separate disparate machines. And then we have lots of sort of internal instances that we use for QA and development, and a lot of these are on the order of 100 machines or so, because they're just sort of basically shrunken down versions of the production network. And so let's see. So like I was saying before, like no single team really has the expertise to sort of maintain like a real good instance, except for the production instance, because the production instance takes lots and lots of resources for us to run smoothly. We have an entire team of people in our network operations control center that are basically watching this production instance 24/7, and are looking at the monitoring data coming out of here and making sure that each server is operating the way it's supposed to. as well as each sort of at the higher level, the software developers are there sort of providing second or third tier support of, well, this machine isn't operating correctly. Why isn't it? And how can we fix it? So it's difficult to sort of to encapsulate that into like a real working internal network instance. I mean. So we find that these instances are labor intensive to manage. And so we'd like to be able to sort of create these as a commodity. And so when I say a commodity, I mean something where I can sort of just, I'm not going to create this out of thin air, and it's not coming for free, but like I can pay some cost. In this, ideally this cost would be in terms of, well, disk space and CPU time and I/O bandwidth or something. So I can press a button, and create an Akamai instance that's working, and that allows me to have this and hand them out to people, to individual groups and even individual developers and individual QA engineers, so they can run tests against this, install the new version of the software, and start running their tests against this thing. And so because yeah, so, but unfortunately, we find that automatically bootstrapping an instance from scratch is possible. And when I say bootstrapping, I mean I start with, like, say a bare set of machines, just like with a basic Linux operating system, like our basic version of the Linux operating system. We have our own Linux distribution that we use. And taking that bare set of servers and installing all of our software from scratch and trying to put all of this state that I was talking about earlier into it, this dynamic configuration, this static configuration, and try to do whatever manual configuration or manual changes are required to turn this into a real working Akamai instance that provides the services that we have. It's possible to do this. In fact, we've done some experiments with making this happen, and we have sort of rough working versions of this. But we find that it's difficult, it's slow, it's error prone to sort of do this, I guess, because every single time that we ever change our software, we have to sort of come up with maybe a new bootstrapping step, I guess, and we don't have a lot of control over, especially the edge networks that are changing their software and causing some new bootstrapping step to be necessary, I guess. And so we don't find this particular approach to be as maintainable. And so we're looking for other ideas about how to make this work. And so the solution that we're looking at right now, and that we've gone a good way towards implementing, is using virtualization to sort of, instead of trying to represent the state externally and push that into a set of machines that we're trying to bootstrap and build into an Akamai network, let's just build the Akamai network using virtual machines, and we can take this well-managed Akamai network, and we can just copy it around, and by just copying the underlying images and moving it around, and that way we can have this well-managed instance of Akamai machines. And instead of trying to represent the state outside, we're representing the actual state of the Akamai instance in the machines themselves, I guess. And so now we care less about trying to represent that state outside, because we just have the state in the machines. That's great. We don't really have to concern ourselves with how are we going to bootstrap this thing, how are we going to represent this data. We just have the machines, we can copy them around. It's just like an object. That's great. And so the nice thing about the virtualization concept, and especially OpenNebula, is that we can abstract away like all of the sort of underlying management that we need to do with the virtualization. Like, we don't have to worry about what physical servers are these VMs going to go on? What does the virtual hardware look like? We just have these virtual templates. What does the networking stuff look like? We have virtual network templates that we can create on the fly. And so the nice thing about OpenNebula, the idea of using like the cloud for this, is we can just sort of abstract all that away And we can use this this cloud concept to say, just give me a machine. Here's what it looks like. Give me a machine. And it'll get scheduled out the way that I want it to using OpenNebula. And it just provides me a nice abstraction that I can use to sort of create whatever sort of machine that I want and create as many of them as I want, as many of them as I have hardware resources for, and allows me to do that. So the idea here is that we're gonna have this QA instance that's got 100 machines in it, and we're gonna take each one of these machines and clone them, and then we're gonna have this copy of this QA instance. And it's going to be an exact, copy. And so, sort of each individual machine, like in order to clone one of these things, it's relatively simple. We just have to power down the VM. We're going to clone each disk in the VM. We're going to add a new virtual network, and then we're going to construct a new VM template that's based on the old VM template, with just the exception that it's going to use a new virtual network. It's going to use the disks that we just cloned. Then we're going to boot the old VM back up, so now it's still running in the state that it was in before, and then power up the new VM. And so in that way, we sort of have two copies of the same VM. And so if we sort of generalize that to sort of say, well, okay, we're trying to clone an entire Akamai instance. Well, okay, we're just cloning every machine in there in the Akamai instance. But the problem that we have is that the way that Akamai machines are configured, the way that our systems work, is that each Akamai machine has a static IP. And so we don't have any provision for using DHCP or anything like that. And each machine not only has a static IP, but each machine, when it's installed and configured, also refers to other machines by their static IPs. And so the static IP, the IP of a given machine, is actually sort of its identification, its ID. So we can't really get away from that. And so and I know there are other solutions that might involve, well, okay, each machine, can change its IP, after it's been cloned or something like that. But it wasn't really going to work for us. And so we had to have a way of sort of isolating these machines such that, when I create my machine that's got the same static IP, we don't want there to be a conflict. So the answer for that was, well, okay, we can just put it behind in a private network and then isolate it using network address translation. And so the OpenNebula virtual router appliance it's sort of a perfect fit for that. I'm not sure if, well, yeah. So this isolates these instances behind these gateways. And so this provides a nice way of isolating, I guess. But we still sort of have the desire to sort of refer to these, sort of reach into each one of these private networks, these private instances, and you manipulate these machines. We want to do software installs to them. We want to use the Akamai services that are inside each of these instances. And so we have a couple of different ways of sort of getting to this. We have the idea of using network address translation sort of in the reverse sense, like where we have an external IP on the outside that allows us to refer to a particular machine inside. We can also use SOCKS. SOCKS is just a proxy method for reaching through an intermediate machine. And this allows us to use some of our command line applications transparently just by using a command line wrapper around them. And we also have this concept at Akamai called OffGate. And so OffGate is simply, it's sort of a drop-in replacement for SSH. And all it is basically is an SSH forwarder. Like, we can create an SSH session to the gateway, and then the gateway, using some protocol, will allow us to create another SSH session to a machine inside the instance, and it'll just connect those up, and it's just like we have an SSH session directly to the machine inside the instance. And so the nice thing about this OffGate thing is that a lot of our tools are sort of integrated with this, and so we can easily do software installs using this OffGate abstraction. and a lot of our other tools are sort of, are aware of the existence of OffGate, and so SSH and this OffGate idea are very pervasive at Akamai. We use SSH for essentially everything. We just find that it's a nice abstraction a lot of the time. And the idea of using OffGate here is just sort of a perfect fit for us. And so we've taken the OpenNebula virtual router appliance and we sort of added support for this reverse NAT idea and the SOCKS idea, and added an OffGate server here that does exactly what we want it to do. And we found it to be very sort of simple to do this, and it's been a very nice way of doing this. Okay, so that's good. Okay, so OpenNebula is great for managing VMs and the resources, like I've talked about. But we really wanted another sort of level of abstraction for our users, our internal users of this sort of instance service. We wanted it to be very simple. We wanted to be able to sort of be aware of the existence of Akamai Networks, these functional units of an Akamai instance, and Akamai instances themselves, and maybe expose some specific Akamai services and machine types as well. And so we wanted to sort of create another layer of abstraction on top of OpenNebula in order to allow us to sort of refer to this Akamai layer of things. And so what we did is we created basically an Akamai instance service. It's service-oriented rather than sort of just being a programming library or something like that, because we wanted it to be programming language and test harness agnostic. We have all kinds of test harnesses and programming languages are used all around the company, and we wanted to be able to sort of provide this service that was agnostic. And so we're using this REST-based, JSON-based web API to sort of provide this instance service. We found that to be a really nice abstraction. And I'll mention here actually that I saw that there is a new feature of OpenNebula 4.2 that allows you to use, that allows you to sort of refer to multiple VMs. I thought that was quite interesting. It's something I didn't actually know about until today, so I'm glad I came to this conference. And so I think that's quite interesting, and it might have some applications here. That might be using that might be interesting for us for this instance service. I'm not quite sure how it's going to apply yet, but I think that's interesting. So this is sort of an example of what the workflow might look like for this instance service. Here you have the user here in the lower right-hand corner, and he's just going to say something like, "Give me an instance, that looks like the one that Joe has over there, because that one's the good one. That one's the one I really like, because that's the one that's actually working and has the services that I need." And so he says that to the instance service. The instance service says, "Oh, I know about that instance. I know about all the Akamai networks that are in that instance. I know about all the machines that are in that instance." And he says to OpenNebula, "Well, okay, take these machines and clone them." And he sort of goes through the steps that I illustrated earlier that are necessary to clone the machines in the way that I'm talking about. And he creates the new resources, and he instantiates a new gateway using that variation of the OpenNebula virtual router appliance that I talked about. And he says, "Okay, here's your instance." And now the user has this instance, and he can use it. And so, I mean, I feel like this is, from the user perspective, this is really quite simple. Give me an instance, and some amount of time later, now I'm ready to use it. Now I have this instance that's available to use. It's nice and relatively easy. Yeah, so now we can create these copies of instances. That's great. So what? So what we're trying to do is we're trying to take this expertise from around the company and to create this internal master instance, for QA and for developers to use. So we can use this instance service to provide something that's actually realistic. And this sort of harkens back to the problem I was referring to earlier, when I was a new developer, I was having lots of trouble with, well, I don't really feel like I have a realistic environment, where I'm doing my testing and development. And so I feel like if I'd had a service like this, at the company, when I'd first started, it would have made things like much easier for me, because like the breadth and the depth of the complexity of the software systems at Akamai is just so high that it's so difficult for someone that's just getting started to really get their feet wet, and sort of having the ability to sort of create these instances and not worry about ruining the state of the instance because you're sharing it with other people, and being able to sort of play with it and manipulate it at will is, I think, just a very, very powerful concept for us, even just for like these internal instances. And so what we're trying to do is we're trying to leverage expertise from around the company to create this internal master instance. And so, this is going back to the concept of we're trying to create this commodity where we don't need these experts anymore, or at least only periodically. And so each additional network gets it closer to a real instance. And so each sort of additional network that we add to this master instance just makes it a more and more powerful concept. And we're trying to get here. This is still in the relatively early stages, I guess. But everything I've talked about we've done, but it's like this is what we're trying to work towards right now, is sort of getting all this expertise from around the company to sort of build this master instance. Okay, so I'm actually doing pretty well on time. And so one thing that's sort of fallen out of this is we're finding that this concept of referring to Akamai instances, which is something that's actually relatively new. Most of the sort of developers at Akamai are sort of stuck on the concept of, well, I have my network and I know about my network and I don't really know about anything else. But like the idea of referring to Akamai as an Akamai instance is, I find to be a very, very powerful concept that I'm trying to introduce that to the other developers at Akamai. And so we find that it's this Akamai instance service that I was referring to earlier sort of gives us the tools and conceptually provides like a nice interface to sort of interacting with an Akamai system. And we're seeing that it's relatively easy for us to adapt this thing to not only providing a view of OpenNebula created virtual machines that comprise an Akamai instance, but also to refer to existing Akamai networks that are composed of right now physical machines. And so we can even use this to refer to our production instance. And so what we're trying to do right now is, develop some libraries, a layer of abstraction that allows us to sort of refer to these instances, very generically, and sort of expose some of the Akamai services underneath, and sort of allow us to use the same tooling to manipulate and do testing on these OpenNebula virtually created Akamai instances, as well as the production instance of Akamai. And as well as sort of existing physical lab instances, which are still important. And so actually, let me go back here, because we find that we have the desire to be able to combine the idea of a physical machine and a virtual machine, because physical machines are very important to us, because we find that, especially since almost all of the machines that we have out there on our network are physical right now. And we want to, when it comes to performance characteristics, we want to have a realistic test, I guess. And so this is a feature that's sort of, that are like users of this internal system have desired, is the idea of like combining a physical set of physical machines with these virtually created machines. And so this is not something we've actually done yet, but I think it's an interesting concept of like combining, a cloud of physical machines with a set of existing physical machines, and sort of referring to those and addressing those with the same interface. And so that's something we're trying to do, because like I said, performance is something that's important to us, and we want to have a sort of realistic testing environment. So let's see, got about 5 minutes. So let's see. So testing at Akamai happens in a number of stages. We have the unit testing, which happens sort of at the software module level, and then we have like a dev QA stage, which is mostly automated testing that happens at sort of the individual software component level, and then we have an SQA stage, which is like where we're testing the system, and then we have this concept that I don't know if like this is something that like other companies do, or, that have big software deployments. But when we make a software release, we do what's called checklisting, because our software releases are done in a staged fashion, and the first stage might be to simply deploy 4 or 5 sort of representative servers on a given network, deploy the new software release to this 4 or 5 representative servers, and then we look at these servers and say, okay, well, are they functioning correctly? And the person that typically does this sort of smoke test or sort of inspects these machines to make sure they're functioning correctly is typically the developer of that software. And we consider the time of a given developer to be relatively valuable, and so we'd rather not have them sort of doing these manual tests. And so we've been working as much as we can to sort of automate this idea of checklisting on the deployed network, especially since like we have this first stage where it's like we're deploying 4 or 5 machines and then doing this inspection, and then the second stage where maybe it's like a couple of dozen, and the third stage up to, I think the media networks have 9 or 10 stages, I guess. And so we've been working as much as possible to sort of automate this idea of checklisting. And then in addition to that, and so this checklisting, a lot of times it's, maybe it's SQL query, against the network. I was referring to the idea of, we have our monitoring and reporting system that, allows us to, run SQL queries against the network. We're using SQL queries, to do this sort of checklisting, as well as just logging into the machine and looking at the state. And then at the next stage here, we have, once a release is completely deployed, we have this idea of alerting, where this automated system sits here and continuously runs this SQL query and looks for problems with a network. Like is this particular value above some certain threshold? Are all these machines up? Is some certain percentage of the machines that are providing this service down? That kind of thing. And so that will alert, and somebody in our NOC, our Network Operations Control Center, will see that, and there might be some procedure associated with it, or they might have to alert the developer. So that's sort of the stages of testing and monitoring that we have. And so what I'm trying to get at is we want to be able to use the same code to write tests by using a common interface to refer to an Akamai instance. And so this concept of an Akamai instance service, I think, is something that's going to really help us to provide that. Because we can combine sort of what are right now really sort of disparate, and sort of there's all this code all over the place that does the dev QA and SQA and checklisting. If we could sort of get all of these different stages of development to use this one common interface to an Akamai instance, I think would really provide us a lot more efficiency than we currently have. And so I think this is a powerful concept, and it's like OpenNebula is really helping us to get there. And so the takeaway here is that we're using OpenNebula to build realistic copies of our deployed network for testing and development. We find this to be just a fantastic concept, and it's just a beautiful way to refer to our network. We're providing this service internally for our testing and development, and it's just been absolutely great. Like OpenNebula is just it's a great project. I've spent a lot of time with it over the last couple of years, and it's something that's really been helping out Akamai, and so I'm really happy to have had the chance to use it and to make some small contribution to the community as well. And so that's it. Thank you for listening. Question? Yeah.
So you mentioned using the OpenNebula router appliance.
Yep.
So how are you seeing the performance of software router appliances as compared to hardware network switches? Is there at some point in your model you think you could actually switch to more software routing elsewhere in your thing based on this, or is it only because?
So the question was, how do we find the performance of a software, router appliance compared to like a hardware-based solution? And the answer is that we haven't really gotten into sort of to the state of like really seeing the limitations of the performance of a software router. And so I think that the real benefit of a software router is the ability to sort of create this thing out of thin air and like not need like an additional hardware resource in order to create, let's say, a new Akamai, virtual instance. And so I don't have a great answer for your question because like I haven't looked at the performance characteristics of a software router versus a hardware router, and we haven't run into the limitations of a software router yet, with sort of the amount of use that we've gotten from this solution. But I mean, and there may be things that you can do with a software router, like to sort of maybe distribute the load somehow. It's not something that I'm familiar with, but I think it's an interesting question, or it's an interesting concept. But unfortunately, I don't have a great answer for you. Anyway, yeah.
Do you need to sometimes, when you create new instances, have the emergent time because you have different administrators that use stuff? Do you happen to need to keep them in sync at some point, or move software from one of the instances to the other one?
Yeah. So the question was, do we ever find that instances are diverging, and do we ever need to sort of synchronize, like, software from one of these, this diverging instance? And so sort of, to answer that, the model that we're sort of looking for is that sort of there's going to be sort of, if you think about this like a tree, you're going to start at the root, and we're going to have this, here's a good, well-managed instance. And people are going to create different clones of that to use for their own uses, and so so somebody you've got all these different sort of copies all over the place, and they're going to be using it for their own purposes. And so the model that we're aiming for is there's going to be sort of the one group that sort of carries forward like the well-maintained instance. And we're the ones that are going to say, okay, well, we're going to create our own copy of this, and then do whatever things we need to do to make it well maintained, and then create another, create a saved copy of that clone, and then when somebody else then wants to have a new instance, they'll create a copy from that. And it could be that some groups may find that they want to sort of go off and maintain their own sort of subtree of this. But we haven't sort of run into that problem yet of having to or wanting to sort of synchronize the state of these instances. But sort of given, as long as there isn't too much of the problem that I was talking about before of like having to do this manual changes and tweaking of a particular instance, it's relatively easy for us to sort of synchronize the state because we can deploy a new software release and deploy new metadata using our distributed file transfer system, and we can synchronize that sort of state relatively easily. But I think just the power here is that we have the choice of doing this. We have the choice. We can now I think it's a good problem to have is to to have multiple copies of a well-managed instance maybe that are just much more powerful than like anything that we had before, and they're easy to sort of manipulate and to move around. I think what you're saying is potentially sort of a problem or maybe a little bit of a pitfall, but I think if we're having such a problem, I think we're in so much of a better position than we were before that it's almost not a problem. Okay. Sure. Yes.
Is the OpenNebula server part of the network itself, or are they
So the way that we've got this deployed in the lab right now is that the OpenNebula servers, the OpenNebula physical machines are sitting in exactly the same place as where the instance service itself and the gateway and the cloud of obviously the cloud of virtual machines that it's created. I'm sorry, the question was is the OpenNebula server sitting in the same place on the network? And the answer is I believe yes, if I'm understanding your question correctly.
Second question about the instance service.
So the instance service is relatively lightweight. All it is really a web application that's just driving OpenNebula. So while it doesn't have to be, because it's not really moving any interesting data around. All it is taking web requests from users and basically making XML RPC calls to the OpenNebula front end. So while it is like in sort of the deployment model that we have now, it doesn't really have to be.
That instance service very Akamai specific, or is it also?
It's unfortunately it is. A lot of what sort of provides the value for us of doing this is that it is sort of Akamai specific, and it knows a lot about like sort of what an Akamai network is and what an Akamai service is and like how to refer to those. I think it's a really powerful concept to be able to sort of take virtual machines and sort of like groups of virtual machines and sort of manipulate those like independently together, I guess. And so that's why I was really excited to sort of see this new feature in OpenNebula 4.2, where it does have some ability to sort of use multiple VMs and sort of treat them as a group, I guess. And I'm sort of really looking at ways that we can sort of leverage that to sort of help us with some of the problems that we're having. Because I think it's a really powerful concept, especially for companies like us that sort of have large groups of servers that we're interested in sort of treating as a group and maintaining as a group. Sure. How many OpenNebula servers are we running? Yeah, so that's sort of an interesting question. Unfortunately, sort of the state that we're in now is I've taken OpenNebula and I've sort of created a distribution of OpenNebula that sort of fits into our deployment infrastructure, and I've sort of taken this and sort of packaged it up for like Akamai use internally. And I sort of said, hey, I'm using this. This is great. Here, other people can use this too. And so, like, there are all these groups all over the company. I'd say, 7 or 8 groups probably that are independently sort of running their own OpenNebula like masters and deployment and stuff. And so now our lab manager has sort of, also sort of, thrown his hat into the ring, and now he's running an OpenNebula deployment that's got hundreds of physical servers in it, and at this point, I'm sure there must be hundreds and hundreds of I don't know the numbers actually, but he's probably got hundreds of VMs at this point. Probably over 1,000 VMs running on this. But the answer, so for our deployment, that's running this instance service right now, it's more like on the order of like 20 or 25 physical machines. And we've got, they're pretty powerful servers, so we can run like 300 or 400 VMs on that. So that's to sort of give you the idea of the scale. But like I said, this is still sort of in the relatively early stages, I guess, and we're trying to sort of build this thing up and provide it as a service for internal Akamai developers and QA people. And so we're still in the relatively early stages here. Yeah, so I hope that answers your question. Sure.
You mentioned that you have a custom Linux distribution. Can you elaborate on that?
Sure.
And how does that affect the OpenNebula packages?
Yeah. Yeah. So the question was, we have our own Linux distribution, and how does that affect having to package up the OpenNebula distribution, I guess. And so, like our internal Linux distribution, I hope I'm not breaking any confidentiality by saying this, but is based on Ubuntu, and we basically take the Ubuntu packages that you guys have, and we sort of I apply like a couple of patches, like at least one of which I've pushed upstream to you guys, but and add a couple of patches to it to sort of make it fit with our sort of custom Linux distribution, and nothing too much different, I guess. It's more has to do, like the custom stuff that I have to do there really has more to do with sort of the deployment. So like I wanted to make it in the idea is that I can write sort of a single Akamai sort of specific configuration file and sort of deploy an entire OpenNebula master with nodes and just sort of deploy that very automatically and have like a Gluster file system automatically created, and then all of this stuff that's needed to sort of turnkey create an OpenNebula installation just from scratch using a single configuration file. I mean, it's pretty similar to like what Puppet or Chef might do, I guess, but it's sort of our Akamai specific thing that does this, unfortunately. Unfortunately, because what we have is great, but it's a little bit, it was created about 13 years ago, and so it's fortunately getting a little bit long in the tooth, but because there are great open source tools out there that do a similar thing. So I hope that answers your question. Okay, we have 1 more minute left, so I can probably take one more question, if anybody's got one. Sure.
Have you considered install the virtual instances on your operational network?
Okay, the question was, have we considered installing a virtual instance that we've talked about here on the operationalized network? And the answer is that I think that's a great idea. Myself, I think that's a great idea because I think we've got applications out there that would find this sort of concept useful. We have products that we sell, managed products that we sell called a managed CDN. We basically take a little mini Akamai and we sort of put behind somebody's private firewall that they use like sort of Akamai services behind their private firewall to sort of derive the benefit of having sort of a CDN. And I think the idea of like doing this using one of these virtual instances is a great idea. And so I'm trying to like sort of build up the momentum to sort of and selling this idea as like sort of a development and a testing sort of tool. And if this concept becomes powerful enough and like people around the company sort of start to appreciate that this is really powerful and a great idea, I'm hoping that eventually this might be something that would be used in an operationalized sense that we might even sell. But we're just not quite there yet. Like I said, we're sort of in the early stages here, and so that's where we are. So I think we're out of time. So I want to thank everybody for listening and for all the great questions. Thank you.